We're on lesson 207, which happens to be chapter 7 in the electrical systems book. Topic of this one is wiring methods. So as you can imagine, this is kind of an all-encompassing kind of broad overview. It's a big topic, so we're going to sort of gloss on a lot of different things here. Quite a few objectives, as you can see. They tell us here, we're still not over grounding quite yet. The equipment bonding jumper may be run as a separate conductor on the exterior of the raceway. That goes back, especially if you think of like a flexible metallic tubing or conduit. And they mentioned if it's over 6 foot long, we may have to run an additional, bonding jumper. That's again if we're using that raceway as a grounding conductor. Also, we need to do that to bond, if it's metal conduit, bond both sides of that conduit on either side of that flexible conduit. Conductors of different systems, 1,000 volts or less, maybe in the same raceway. This one, I think, gets called into question a lot. It's actually fine to do. We need to make sure we have distinct, color schemes. So particularly for 480 volt, you're going to use brown, orange, yellow. 208 volt, you're going to use black, red, blue. Another caveat is all the wiring has to be rated to handle whatever the maximum voltage is. And coincidentally, most of our wiring types are rated up to 1,000 volts. So provided we meet all that, we can have two different voltage systems, wires in the same raceway. Conductors subject to physical damage shall be protected. That goes without saying. A big one you're going to see is like maybe in a garage. You think residentially, you're running Romex, or in a basement, you might see some conduit coming down to protect them. They get into the basically a nail plate here. If we are less than 1.25 inches from the face of a stud, that's the magic number, 1.25 inches. We need to put a 16-inch nail plate in there. All cables and raceways approved for direct burial shall meet minimum cover requirements. Hopefully this information looks familiar, but I think where it's really familiar is 300.5 from your code book. That's our burial depth. You guys should remember from year one. But anything underground must abide by the depth found in 300.5. Spend some time to refamiliarize yourself with this, because you're going to see a lot of questions related to this table. Underground installation of direct buried cables or raceways shall be protected. Here again, they're basically telling us we need to have them in appropriate conduit or raceway. We need to have our appropriate burial depths. We know we don't want to have rough backfill, anything like that. Again, that kind of stuff I think is pretty common sense type of stuff for the most part. This is one I don't know how many people are aware of. Maybe you are. Maybe you're probably doing it. You don't know. But a 1/4 inch airspace is required in wet locations, so there's no entrapped water or moisture. If you ever notice those little bump outs when you have a piece of 3R equipment, those are about a 1/4 inch, and that actually achieves this airspace sort of by default. Right? Installed raceways, portions of raceways, or sleeves that are exposed to different temperatures shall avoid condensation and allow for expansion and contraction. So they have special expansion fittings. If any of you guys have done any work in refrigerated environments where you have a raceway going from a unconditioned space to a refrigerated space, it's a common problem if you don't seal those raceways well enough. You're going to have condensation building up. Obviously, condensation can freeze, or in our case, worse yet, turn to water, which is not a good thing for electrical connections at all in either case. A non-current carrying metallic parts of electrical systems shall be bonded together with permanent and continuous bonding. Usually our raceway systems are continuous if it's a metal system, but in this case we have some PVC, and then we have a metal cover of a junction box, for instance. So this PVC would isolate it from, by our normal means of conduit, but the PVC conduit has no conductivity. We need to do some extra bonding on this metal cover. Or maybe this whole box was metal and it was PVC conduit running into it. Or even if it was metal conduit with a PVC box, we would need to jump out these two conduits to keep that non-current carrying metal parts all bonded together. Wiring systems installed above a roof ceiling assembly shall have an independent means of support. This is one we're probably all almost familiar with. We need to support our wiring above essentially a drop ceiling here, right? We need to do that separately from any other sort of building system supports. We can't use the ceiling guys tie wire. We got to use our own, drop our own tie wire down. And most times, and I'm hearing it more and more, you're going to actually need to see it marked. Usually, they'll spray paint it, something like that, to indicate it is separate from the ceiling support, right? The grounded conductor of a multi-wire branch circuit shall not be dependent on device connection. Okay, that's a good one, and probably gets violated quite a bit. Think about a receptacle here. If you got one cable coming in, one cable going out, you're gonna have two hots, you're gonna have two neutrals. If this is a multi-wire branch circuit now, so essentially we're talking about a shared neutral circuit, we don't want the continuity of that neutral wire to depend on whether or not I took a receptacle out. Because how common is it? You turn the breaker off, you start working on it. Unbeknownst to you, that's a shared neutral multi-wire branch circuit. If you take that neutral off your two screws of your receptacle, you've now got an open neutral. There could be a load from the other circuit on there. That's a very dangerous situation. Um, Even if it's not a multi-wire branch circuit, it's good practice to wire nut and pigtail onto your devices rather than depend on the device. But if it's a multi-wire branch circuit, it's actually a code violation. Now we all know too we should be using a double pole breaker if we're sharing a neutral, so we don't have any choice but to turn both hots off. But again, that doesn't always happen. In the past, it certainly didn't always happen. Grounded conductors shall be spliced together to prevent any open neutral and shall not rely on the device for continuity. So there is just kind of a repeat of what we talked about here. Again, you're going to wire nut, pigtail out to your neutral rather than take this neutral and that neutral, put it on your device. If I take that receptacle out, especially if it's a multi-wire branch circuit, I have an open neutral now, and maybe unbeknownst to me, again, very dangerous situation. A box, conduit body, or fitting shall be installed at each connection or pull point. So we're never going to obviously make a splice, in the middle of a conduit, but we need a box anywhere there's a pull point. If we have over 360 degrees of bends, we have a pull point. You got to have something there. You got a conduit body, a box, whatever the case. A box is not required at the transition from a cable to a raceway system. I don't know if you've seen this, but that's actually maybe I see this a lot in like an older apartment. You have a brick wall finish. They want to run exposed conduit up the brick wall, but you get up to the ceiling, which is now a drywall ceiling. We're going to run MC or Romex in our above our ceiling, and then we can actually have a transition to go from MC or cable, whatever, to our conduit. We don't actually need a box there as long as there's no splice there. Nobody's pulling wire back through this cable, so it would be no different if we just ran the cable all the way down. So we don't actually need a box, but you do need an actual identified fitting. A lot of times for the smaller stuff, they'll make a fitting just for that MC on one side, EMT on the other. Sorry about that. But if you get into the bigger stuff, or maybe you don't have the fitting, use an EMT connector, rigid coupling, and a MC connector on that side. Essentially, it's got to be stuff made for the purpose of what they're getting at. All AC phase conductors, grounded conductors, and equipment grounded conductors shall be grouped together. So we're not going to run our conductors in separate conduits like this. It's kind of a stretch to think about why you would do that or how that would happen. But all your conductors of the same circuit must be in the same raceway or cable. Right? Openings in fire-resistant walls shall be fire stopped using approved methods. Some kind of fire caulk usually is what you guys see, especially as an apprentice. You get stuck doing the fire caulking. Here they just mentioned some types of cable that can actually be run in plenum spaces. So plenum spaces, when they actually, a lot of times when we see it, is the entirety sort of the above ceiling is a plenum space. We need to use plenum rated cable or conduit or raceway. Non-metallic cable may pass through a closed-in starter joist space used as a return in a forced air heating system. If you don't do any residential, you might not really know what you're talking about. But residentially, they'll just take this stud bay space, cut a register in here. This is actually now sort of their plenum space. They're using this as an air duct. For plenum reasonings, can we run our cable through there? Well, you can, but you got to go straight through. I couldn't come vertically up and down this stud. I can only go straight through, nothing else. And so again, that was a whole bunch of different stuff there for you guys. Kind of a gloss over lesson, but spend a little time on it. I think it's all going to come back to you and look pretty familiar. As usual, any questions, don't hesitate to reach out.